So let's have a look and see how we would go through and do this. So we have these two matrices, and we want to be able to find the inverses of them. Now, both of them theoretically should be able to have an inverse because they are three. They're both square matrices. But just because they're a square matrix doesn't mean it's going to have an inverse. Okay, it just means it can. Whereas if it's not a square matrix, there is no way, shape, and form that there's going to be quote unquote an inverse of that matrix that I can multiply to it to make it an identity matrix. This won't happen. If I want to find the inverse of matrix 2, 3, 3, 5, I'm going to take that matrix and I'm going to augment it with the 2 by 2 identity matrix. And what I want to do is perform row operations that's going to make the left-hand side, the one that's on the left of the vertical line, into the identity matrix, and then the matrix I have on the right should be the inverse. So, much like before, I have a 2 here. I would like it to be a 1, so I'm going to basically divide row 1 by 2, or multiply by a half. And so these become 3 halves, 1 half, and remain 0 specifically. I established the 1, which means now the 3 that's down here needs to become the 0. So I am going to take row 2, and I'm going to subtract away 3 times row 1. And that's going to put the 0 down there. 5 minus 3 times 3 halves is going to be 1 half. 0 minus 3 times 1 half is a negative 3 halves. And 1 minus 3 times 0 is still going to be 1. So far, so good. So I now have this column established. Anything I do beyond this, that column should remain unaltered. So I'm going to do I'm going to do 2 times row 2 because I want this to become a 1, which it does. And then if I do negative 3 halves times 2, I get negative 3, and 1 times 2, I get 2. The last thing I have to do now is get this to be a 0. So I'm going to take row 1 and subtract away 3 halves times row 2. 1 minus 3 halves times 0 is 0. So again, this has remained unchanged. Let's see. 0, or 3 halves minus 3 halves times 1 gives me the 3 halves minus 3 halves, which is 0, which is what I wanted. 1 half minus 3 halves times negative 3 does give me 5. And 0 minus 3 halves times 2 gives me a negative 3. So this is what I end up with on the right when I carry through the row operations for this special augmented matrix, which means that is the inverse matrix of 5, negative 3, negative 3, 2, reading down the columns. I'm going to write it as an augmented matrix. I notice that in the upper left-hand corner I already have a 1, so that's pretty easily. I just have to get, this 2 here and this 2 here to become zeros. So I'm going to take row 2 and subtract away 2 times row 1. I'm going to take row 3 and add 2 times row 1 to get the new row 3. Row operations for this steps are going to be row 2 minus 2 times row 1 and row 3 plus 2 times row 1. And if I carry them through, I get the zeros where I want them on the left-hand side here. And then each of the other cases, like for instance, 1 minus 2 times negative 1 gives me 3. 2 minus 2 times 3 gives me negative 4. So forth and so on. I'm not going to go through each of those. You'd have to carry through each one of those calculations, but that's what you would get. And so Again, if I'm careful about how I do this now, this column, which now has the 1 and 0s where I like them to be, should stay that way. Next thing that has to change is I want this to become a 1. So I'm going to take row 2 and I'm going to multiply it by a third, divide by 3, whichever way you want to put it. And if I take the entire row and essentially divide it by 3, that's what I get with row 1 and row 3 being unaffected. Now that I have the 1 right here, this and this need to become zeros. So if I take row 1 and add row 2 to it, that would just make, the numbers in those positions, the negative 1 become a 0. And likewise, if I want to take negative 4, I'm going to add it to 4 times row 2, and that should make that one a 0. So the row operations are, I'm going to take row 1 and add row 2, and I'm going to take row 3 and add 4 times row 2 to it, and that's the result I get. So I have the 1s and 0s where they all need to be in the first 2 columns. And again, if I keep continuing this the right way, that those are not going to change anymore. This should remain static for the rest of this problem. I now want to make the 8/3 in the bottom right hand corner on the left side into a 1. So I'm going to multiply row 3 by 3/8. And as far as the rest of it goes, 2/3 times 3/8 is 1/4. 4/3 times 3/8 is 1/2, and 1 times 3/8 is 3/8. Now I just got to get these two numbers here and here to become zeros. So I'm going to subtract 5/3 times row 3 from row 1, and I'm going to take row 2 and add 4/3 times row 3 to it, so I could get the zeros and ones all lined up where they're supposed to be on the left and finish that part off. And when I do that, the top row becomes 3/4, negative 1/2, negative 5/8. The middle row becomes negative 1, 1, 1/2. The bottom row, of course, had finished in a previous step or two. So that would be the inverse of the matrix. The inverse of this matrix would be this matrix right here. I'm not going to read it all. You can see it, but that's how you would have to write it.